and today I'm going to be going over my final project for the computer vision class. So I decided to do the general project, which was creating a new data set of 1,000 images and then testing it with a state-of-the-art model. So here in my README, I have the summary slash description, which this first paragraph says the problem that I'm addressing, which is that the ImageNet 1000 dataset, which is a subset of the full, very popular ImageNet dataset, does not classify specific breeds or species of animals very well. The example that I found in a research paper here was that the J class in it is majority blue jays, even though they were either inaccurately described or there are 49 different species of jays around the world. So 62% of that set being just blue jays is not a good reflection of what actually happens in the real world. So to combat that, I decided to do 10 different breeds of ducks. So there will be 1,000 images of each type of duck. The specific breeds are here. And then I am testing it. The state-of-the-art model that I'm using is the EfficientNet BO model, which is from Keras, which is found. The architecture that I'm using is from this citation 2, and then more information about it is here in that citation 3. So here, all the zip images or the zip files contain all the images that I've used. So all duck images is all 1,000 images separated by breed type. And then I have train.zip and test.zip, which are done in an 80-20 split of the entire 1,000 images, randomly chosen. So train has 800 images and test.zip has 200 images. And then here is the code that I compiled, which I will be running in VS Code. This is just a brief look at it. Here, showed a image just to make sure that they loaded properly. And then here are the epochs for training and then the test results that I'll be going over when I run the code. Here are my weekly logs. So here's my week 1 log, which just describes that I created the GitHub, did some research on what I wanted to make the project of, and then I started wrote the README file and then started making the data sets. Week 2 was mostly finishing off the data set, so I completed for the other 9 breeds and then cropped all the images to be 1-to-1 squares so that they were the same for training, and then did the train test split and then uploaded them to GitHub. For week 3, I tried these 3 different state-of-the-art models to determine which one I should use for my final results. I originally used the image class of the VIT image classifier, and it did not perform very well. This convnext tiny took a very, very long time to run, much longer than the VIT or the EfficientNet, so I did not use that one. And the EfficientNet was able to balance both accuracy and efficiency, so that is the one that I ended up using at the end. And then here are my references for each of those. And then for week 4, I just tried different parameters with the EfficientNet, tried different image sizes, tested different batch sizes and epochs to get a test accuracy of 40%. And then for week 5, the final week, I created a graph, which I'll go into in a second, showing the accuracies by the epochs and the final test accuracy, wrote the results.pdf, which I'll also go over in a second, and then, of course, recorded this video demo, and I'm going to upload it to YouTube, and then after I do that, paste the URL here so that it links to that YouTube video. And then here are the results.pdf. So pretty much what I summarized in here was that even though the accuracy for training, so up to this 30 here, because I used 30 epochs, this is all for the training, and then this last one here is the testing accuracy. It did progressively get higher and higher with, I believe, the highest accuracy in training was 94%. However, the testing accuracy was only 40%. Which means that the model was significantly overfitting to this data set. And then here I just discussed that I think we should use in the future, if you expanded this data set to be more robust and have more images per breed, it would probably do better in being able to classify them correctly. So that is pretty much the entirety of the repo. The only thing I need to do is go back and add that URL once I upload this video to YouTube. So now we can go over the code, which I have here. So this cell just goes over all of the libraries that you need to import to be able to run the code. I just put them all at the top together. So we'll go ahead and run that. Here is me prepping the data set to go into the model. So this cell is enumerating the class labels. So here I have all the different classes, which are just the different breeds of the ducks. And then I'm enumerating here into an index so that they're actually numbers and not strings. So we'll go ahead and run that too. And then here, these two cells are pretty much the exact same. The top one is for the training set and the bottom one's for the testing set. This is me initializing the images array and the file names array and importing the path to the training data, which is just stored on my computer. Here's me actually creating the data set, making them 128 by 128, using making them color images instead of black and white, and saving the images and the names to those arrays that I initialized here. And then here's making the actual training sets and the labels that I will be using in the data, for the model. So we'll go ahead and run that. And then here is the exact same thing for the testing data, which is the exact same here from the training, just of course using the path for the test. So we'll run that. So it'll go once the training set is all saved, which might take a second. So I'm just going to cut to when that's all done. So now that both data sets are loaded, I'm going to, this cell just displays one image. I just picked the third one, or index 2, from the test set to make sure that the image lines up with what the name should be, which it does. This is a wood duck, so that means that the images are saved properly into the variables, and that also they do line up exactly with what the names should be. So now here we can get into the model. So here the backbone is the EfficientNet BO, and I use the input shape as 128 by 128 by 3, the 3 being, because it's in color, pooling average and weights none. I did have the choice to make the weights equal to ImageNet because the EfficientNet BO from Keras is was trained on ImageNet, and that's an option for the weights. However, since I'm trying to fill the gap of the ImageNet 1K, which is the subset, not having good biodiversity measures, I did not opt in to have any weights for that, so that's why that's none. And then here's actually building it with the inputs and the using the backbone and the outputs. With the output being 10 because there's 10 breeds, and softmax because we're doing classification. And then here is the learning rate, which I did 3E minus 4, sparse categorical, and I did the metric as accuracy, so we can run that. Now that that's done running, we can go down here to where the model will be actually training the model. So here you can see it has the batch size 8 and the epoch 30, so we will go ahead and run that. And it should take about 30 to 45 minutes to run, so I'm going to cut to when that's all done. So the model finished training, and it took about 43 minutes and 8 seconds that it says here. And now we can see the entire accuracies and losses for the epochs. So it starts very low at 0.16, which is about 16% accuracy, and then jumps to 0.23, 0.35, and around epoch 17, so about halfway through, it jumps to 0.9. And then it stays about 0.9 all the way up to epoch 30, which is at 0.93. So that also aligns with the graph that I had made, where it starts out quite low at the beginning, and then slowly about halfway gets to about the 80 mark, and then goes around 93, 94-ish towards the end. So now we can run the testing model, which is here. to see what accuracy we get for the testing set. So it took about a minute for the testing model to run, and it gave a accuracy of 44.5, which is very close to the 40% that I had mentioned earlier. So that is the entirety of the code with setting up the data sets, loading them, showing an image, and then running the model training and testing, which is reflected here in the GitHub repository under the notebook. Which also has all of the same cells. Of course, the outputs for the models will be a little different because it is running again, but everything matches up fairly well.